Hi,
Hello!
welcome back to Dad and Kids Coding, where we're working on Advent of Code 2020, and we're currently starting day 8. So this is the first of probably several programming. We're programming, but we're going to emulate a computer. And the description is that there's someone gives you a handheld game console that has a loop in it, and what's called an infinite loop, which means it never finishes. And so we have to emulate this instruction sequence and see what happens. So there are 3 kinds of instructions. There's an ACC, or accumulator instruction, which adds or decreases a value called the accumulator. There is a jump instruction, JMP, which jumps to a new instruction relative to itself, and there's a no-op instruction, which does nothing. So this is the sequence that we're looking at, and just copy this as a... so this shows you the sequence that these instructions are visited in: 1, 2, 3, 4, 5, 6, 7, 8, and this is back to revisiting an instruction a second time, which is going to make it an infinite loop, because now it's going to again go to here, to here, to here, to here, to here, and back to here, and keep doing that. Okay, so what we're supposed to do is we're supposed to execute the instructions, and when we get back to an instruction for the second time, we're going to stop and report what's in the accumulator. So immediately before the program would run an instruction a second time, the value in the accumulator is what we're supposed to report. So so we're supposed to do 5 in this case. So this, I've already copied over the data for day 5, so we'll get to that shortly. So now let's add a test for day 8, sorry. Test day 08, and we'll do the A version of it first, and we'll say self assert and AOC day 08A with the string, and this should equals 5. So let's go back and paste that in. So that's the sequence that we were given, and let's just add the other self assert AOC day 08A with self data day 8. And we don't know what that's going to return, so we're going to say that that equals nil. Same as before. Okay, so there's our test, and let's run it and see what happens. Okay, so we get that this didn't understand day 8A, not surprisingly, so let's create that instruction in Advent of Code, and here we go. So let's, so for this, I've done Advent of Code before, and we're almost guaranteed that we're going to have we're going to have more of these programs that we have to implement. So I'm going to create a new CPU, and I'm going to set it equal to let's just call it CPU. New with the string lines. Okay, so we're going to initialize the CPU with this, and then we're going to say CPU run, and then return CPU accumulator. No, CPU, not cup. Okay, so we're going to load it up with the instructions, run the CPU for until it halts, and then return whatever the accumulator value is at that point. So we need to, CPU is going to be a new class, and sure, that looks fine. And CPU lowercase is just a temporary variable, so we're done. Okay, so let's, now that we've done that, proceed. Oh, didn't. Let's just go back to this. So let's say new load. Just going to change the way we create this. Okay, so proceed. And CPU did not understand load instruction. That's fine. Okay, so we'll define this in CPU. And the CPU is this collection of instructions. And let's just say our collection do instruction, and just say self add instruction, instruction. Yeah, that should work. Just trying to decide whether it's the best way, but it's a perfectly reasonable way, so we'll do it that way.
Yeah, so you're not going to use add instructions?
No, because I'm calling it each time with one instruction.
Okay.
Okay, so we'll proceed, and of course it's going to complain that we don't have an add instruction. So we'll create that in CPU. Now we're given a string here, and so if we say substrings is a string substrings, so now save temporary variable and step over that. And now substrings is an array which has two things in it. One is the NOP and one is the number. So let's add to the instructions, add, and let's create a new instruction based on the opcode. So let's create a dictionary which will map the opcodes into the type of instructions. So we're going to create more classes for the various kinds of instructions that we have. So I'm going to say add instructions, add opcodes at SS first. So we'll do that, and then so that's going to return a class, so we'll create a new instance of that class, and then we'll tell it that it's with argument is going to be SS last, or second, let's do second. And CPU is self. So I'm going to make it so that the instruction knows what the CPU is that it's referencing. Okay, so that I think is all we have to do here. So we'll save that. Variable instructions. Okay, I want this to be an instance variable. And opcodes is going to be, actually I wanted that to be a class variable. So I'm going to, opcodes is going to be a new class variable. Okay, now I need to go and initialize because I need instructions to be created as something, and I need opcodes to be set up. So I'm going to leave this and go over here. So now I have the CPU class, and I'm going to create instruction classes as well. So let's just call it CPU instruction. And so let's save that. And then we're going to have several CPU instructions. So let's call this CI NOP for the CPU instruction for the NOP, CI jump, and CI ACC is the third one. Okay, so now we've got CPU instructions, and we have three kinds of sub-instructions. So let's go to the CPU, and we want to define on the class side, and we want to set up this class variable opcodes. So let's create a new class side method, initialize. And here we're going to say opcodes is going to be equal to, or it's going to be assigned a dictionary, a new dictionary. Then we'll set opcodes at NOP, put CI NOP. So what I'm doing is making a class that has the, or a dictionary that maps the keywords into the various classes. So opcode at jump, put CI jump, and opcodes at ACC, put CI ACC. Okay, and that's all we have to do here. Let's run it. So now opcodes, if we inspect this, is these values. So that's good. Let's go back over to the instance side, and we need to add a method for initialize. And first of all, we'll do super initialize, as we always do on the instance side. And then we'll say instructions is an ordered collection. That's all we need to do for the moment. So let's go back over to our test and run the test and see how far we get. Okay, so an instance of CI NOP did not understand argument. Okay, so let's create it. but we don't actually want to put it in not because all the instructions are going to need an argument. So let's put this in CPU instruction, and we're going to say argument is going to be a string as number. So we'll say we want argument to be an instance variable, and okay, proceed. Now number parser, why is this? Let's go back to argument, and as number was +0. Oh, so I can't, that's not legal, apparently. Expect? No, because it expected a digit between 0 and 9. Okay. So, I guess we'll just say if a string first is a plus sign, if true, we'll do this. All but first. So we'll skip that first character if it starts with a plus sign, if false. We'll just do that. Okay, hopefully that works. Proceed. Okay, so that worked, and now we're looking for the CPU instruction. And we'll create that. Again, we'll put it in instruction, and we'll just say CPU. CPU. Okay. And we'll see later why we want this. So I want that to be an instance variable. Okay, so proceed. And now CPU did not understand run. Okay, well let's create a run instruction. Define run in which class in CPU. Okay, so what should we do here? Well, first of all, we should set the program counter to 1 because we're just starting at the first instruction in the instructions. And then we're going to so we'll say if instructions at PC is first execution. So we want to run until as long as each instruction we come across, this is the first time it's being run. So we'll let the instructions keep track of whether they've been executed. While that's true, we want to do something else. So we need to execute this instruction. Oops. So we need to, I guess, execute that instruction. So let's remember this instruction when we do this. So instr, and let's just execute that instruction. Oops, instr, execute. Now, so what we're going to expect is for that instruction to advance the program counter appropriately. It's going to do whatever else it's going to do and advance the program counter appropriately. So we'll save that. So PC is going to be an instance variable, and inster is going to be a temporary variable. Okay, so let's proceed now. And everything's going to go fine until we say is first instruction. Okay, so we'll create this. Again, we'll put it in the CPU instruction, and we'll return if let's just return an instance variable called is first execution. But of course, that means we need to save, make that an instance variable. And that means we actually have to initialize it to something. So let's go back out here, go back over to the CPU instruction, and we need an initialize method. Initialize. Super initialize, and then we need to say is first execution is going to be initially true. We might need to make something more sophisticated later on, but we'll go with this for now. So let's run test day 8 again. So it worked fine. It is first execution for this instruction. Program counter is 1, and we're going to call the instruction and tell it to execute. So let us, and what is the instruction we're doing? We're doing a NOP. Okay. So a NOP doesn't do anything except what every instruction does. So let's just update here. So what we want to do is in a NOP instruction, we just want to advance the program counter. So let's say CPU program counter is going to be CPU program counter plus 1. So we'll just advance the program counter by 1. And proceed. Of course, there isn't any PC method, so we'll create this and we'll put it in CPU. And it saw an instance variable there called PC, so it assumes that's what we want, which it is, so we proceed. And now it doesn't understand PC colon, which is to assign it. We'll put that there. And again, it sees that there is an instance variable called PC, so it assumes we want to store this, which is what we do want to do, and so we're going to proceed. Okay, so subscript out of bounds 10. Because every instruction now is doing the same thing, it's just advancing. So we have to go and we have to add some execute instructions for the jump and the ACC. So let's do it for jump first. So we'll define a new instance side instruction called execute. And let's go and look and see what we're supposed to do for a jump instruction. Jump instruction jumps to a new instruction relative to itself. So PC is pointing at the current instruction. So, for example, jump 2 would skip the next instruction, jump 1 would continue to the next instruction. Jump 20 would cause the instruction 20 lines above to be executed. So all we have to do for execute here is say CPU PC, PC is equal to CPU PC plus argument. Because the argument, remember, if it said it was a 1, we were just continue with the next instruction. So that's all we have to do. So we'll save that. And we may as well do the ACC one while we're at it. So we'll add an execute instruction. And what's the ACC instruction is supposed to increase or decrease the global variable called the accumulator by the value given in the argument. For example, ACC plus 7 would increase it by 7. Okay, so all we would need to do is tell the CPU accumulator to be the CPU accumulator plus our argument. And then we'll tell super, we'll execute the super execute instruction, because that's going to go and advance the program counter to the next instruction. So we'll save that, go back to our test and run again. So we need an accumulate. Oops, we should add that to the key CPU initialize. Okay, so that's the instructions. We also need an accumulator. And it's initially 0. And that's an instance variable. Okay, so now let's go back over here and execute this. And we need to create an accumulator method, create in CPU. There already is one, so it does the right thing. It needs a CPU accumulator colon, and again in CPU, and again it creates the right thing. And proceed, and the test took too much time. Because, let's go and look at our execute loop in run here. It checks to see if first execution is true. And while it's true, it's going to loop. But if we go and look at CPU instruction and we look at the variables, his first execution is set in the initialize to true, and it's returned there, but it's never set to false. So that's not going to work very well. So let's, the execute should probably also say is first execution is false. And that would work because both ACC and NOP call that execute, but jump doesn't, so we need to also add it here. And so is first is false. Okay, so now let's try one more time, run our test, and it says that the accumulator has, so the first test worked, it returned the 5, but now our data executed and it's 1501. Okay, so let's assume that that's the correct answer. And now we'll go over to and then proceed. Okay, and now go over here and input that as our answer. And it's right. Okay.
Woo! You know, off camera, we should probably see if we can code up some command that we can put in instead of nil, so it'll automatically fill itself out.
Okay, good see about that. After some careful analysis, one instruction is corrupted. Somewhere in the program, either a jump is supposed to be a NOP or a NOP is supposed to be a jump. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly one jump or NOP, you can repair the boot code and make it terminate correctly. Okay? So the same program from above, if you change the first instruction from NOP 0 to jump plus 0, it would create a single instruction infinite loop, never leaving that instruction. If you change almost any of the jump instructions, the program will still eventually find another jump instruction and loop forever. However, if you change the second to last instruction from a jump -4 to a NOP -4, The program terminates. Instructions are visited in this order. Yes. After the last instruction, the program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the instruction program terminates, the accumulator contains the value 8. Fix the program so it terminates normally by changing exactly one jump to a NOP or NOP to a jump. What is the value of the accumulator after the program terminates? Oh.
Oh no, I hear that tone of voice and immediately know doom is afoot.
Yes, doom is afoot. So basically what we have to do is we have to try changing every single NOP in one at a time in the program to be a jump, or change the jump to be a NOP. Okay. So,
I think I jinxed it because in my head I thought, wow, it's so nice to finally have the first answer be so quick rather than take up a separate episode.
yeah. So let's go back and see what we can do. So it's not too painful. Okay. So let's make it day 8B and B and B and nil. And what was the correct answer for this one? So value 8. Okay. So we should see 8 here if we do it right. Oops. 8. Okay. So, okay, let's go and see what the advent of code day 8A looks like. So day 8B is going to be just like this, except that we're going to so we're going to have to change CPU run because we want to return when it gets to the falls off the end of the program. So we're going to have to make that change. But for day 8B, what we want to do is we're going to do the load. That's the same as before. But now we want to do the run by it executing. Okay, so let's iterate through all of the. So 1, 2 instructions. What's it called? Instructions? Oh. 1, 2 CPU number of instructions. Do. And this is I. And so we're going to do something here. So we're going to try. So I'm going to change CPU run so that it will return return true if it executes, if it terminates normally, and will return false if it fails. Okay, so let's take this out and move this up here. So what we want to do is tell the CPU to toggle NOP jump at position I. So we'll try changing that. And then we'll try running the CPU. And if that's true, then we return successfully, we executed correctly. And so in that case, we're going to return the CPU accumulator, same as before. Okay, so if that's true, then we'll return the CPU accumulator. Otherwise, we need to toggle it back because we don't want to leave that one messed up. So we'll toggle I back, and then we're done. Now, if we were writing defensively, we'd do something about if we get to here without having found an answer. So actually, let's just do that. No, that's not. Okay, so we have a couple new instructions that we have, or new methods we have to add. This one's pretty straightforward, and these are going to be a little bit trickier, but not a problem. Okay, so let's save this, and then go back and run our test date. Okay, so we didn't understand number of instructions. No surprise there. So we'll go over and define this, and this is just going to be return instructions size. Okay, so that's easy. See, now we get toggle nop jump for number I. Okay, so let's create that. It's in the CPU, and so now what we want to do is we want to say that instructions at an integer is going to be, we're going to put instructions at an integer, but we're going to tell it to toggle nop jump. Okay, so what we'll do is we'll make nop return a new jump instruction and jump return a new nop instruction. Okay, so let's proceed. And of course, a nop didn't have a toggle nop. So we'll create this and we'll put it into inop. And so what do we want to do here? We'll just return, so we're in the nop code, so we want to return a CI jump instruction, new, and we want to set its argument to my argument, and its CPU to my CPU value. And that's all we have to do. And we'll save this because the one in jump is going to be very similar. So we'll save that and proceed. Instance of small integer did not understand first. Okay. Oh, because this is already a number. So probably what this means is well, there's a couple ways we could do it. I'm going to do the really dumb way, which is just to say I'll do this as string. So I'll convert to a string and then I'll convert back to a number. Not the most efficient way to do it, but it'll work. Okay, so instance of CPU did not understand if true, and that's because run didn't return the right thing. So let's go and fix run. So in the CPU, the run method is going to say so if we get to here, we'll return false because we fell off, or we got the problem. And otherwise, we'll say here, after we've executed the instruction, we'll say if the program counter is greater than the instructions size. Oops, should have just been greater than, not greater. If it's greater than the instruction size, if that's true, then we're going to return true because we were successful. Or we fell off the end of the program. Okay, so let's go back to our test again and run our test. So jump didn't understand toggle knock jump. Okay, well that's easy enough. We'll create one. And we'll tell it, we'll put it in CI jump. And if I've still got my, yes I do. Okay, so I want to create a CI NOP instead. Otherwise the same. Proceed. And one, oh, but I didn't fix that because I didn't do the add string because I added that afterwards. A string, as string. Save. Proceed. Now CI ACC did not understand toggle jump. Okay, well let's create one. And this one doesn't have to do anything, so we'll put it up in CPU instruction. And what we're going to do is absolutely nothing. So let's proceed. And got an advent of code instead of 8. Okay, so that's fine. It's because in our method here, if true, return CPU accumulator, and this, I guess, so halt, because it appears that we ran off the end, or, okay, so we didn't find an instruction that changing it made it work. So maybe the problem was CPU run. Let's restart this and step through into the instructions. Okay, so okay, let's step through again. Toggle a not jump, and then let's step into the run. And run resets the program counter. Huh.
Do you mean to put 2 greater thans there?
Where? Oh, that's fine.
Okay.
That's a good catch, but it's fine. Let's just see what. So here.
Looking at this, it sort of reads like a Dr. Seuss poem. A clanop, a clack, a kajimp, a clack.
Yes, it does read like Dr. Seuss.
Sounds like a poem made by a reindeer.
Okay. So I'm a little confused here.
As you should be when reading poetry made by a reindeer.
Because here we should be changing instruction 2. Oh, but instruction 2 was just a, yes, was accumulate. So step through again. Okay. So let's just look at CPU. And CPU. CPU has a NOP, accumulate, a jump. And then when we execute this instruction, and now look at it, that jump is a NOP, okay, which should be right. And which one was it that it said? If we change that last one from a NOP -4 to, okay, so let's step through this. And so I'm doing this until I is 5. So this is 1, 2, 3, 4, 5, 6, 7, 8. It's 8 that we're interested in. So I'm going to skip over these until we get to I being 8. I7, almost there. Okay, so now I is 8. So let's look at the instructions. And let's just look at the instructions. In particular, let's look at instruction number 8 is a jump. And it's a jump -4. Okay, so now let's step through that toggle NOP. And now we're back here. Let's look at, it's a NOP. Let's just make sure it's the right NOP. It's a NOP with an argument of -4. Okay, so now let's step into this run and see if we can figure out why this is not doing the right thing. So step over this. Instruction is instruction at PC. So this is a NOP. Is this first execution? Ah, there's the problem. We didn't reset all the first executions. Right. So when we're going to start to run, not only do we have to reset the program counter, we also have to reset all the first values. So let's say instructions do, and I'm just going to say yeah, should work. Set first execution. Okay, so now let's step through. Step through. Does not understand set first execution. Yes, of course it doesn't understand set first execution. So we're going to instead tell it in CPU instruction, set first execution should be is first execution is true. And proceed. Okay, so it almost worked. Oh, let's just try again because we didn't reset the accumulator as well. So in the CPU, when we do a run, we not only should set the PC to 1 and reset all of the first executions, we should also set the accumulator to 0. Okay. And now when we run this, we get, it runs through the first one correctly, and we get 509 for the second one. Let's assume that that's the right value. Save, proceed. Okay, and go over here and try 509 and submit.
Whoa!
Yay! Okay, so we completed day 8. So, that's all good. Everything is already clean. I don't think we need to do anything, any kind of cleanup here. So let's just commit to our repository. So, day 8 complete. 2 stars. And let's just review the code before we do this. So what did we do here? We have quite a lot of instructions. So we added the day 8 A and B, and then we added several classes: CI ACK, CI jump, CI NOP, CPU instruction, and the data for day 8 and the tests. So we're all good. So we'll commit this, and it's pushed, and reload. Oh, I got it. And committed at 11 seconds ago. So we're done for today. So thank you for joining us again, and we'll see you tomorrow.
Yeah.
Bye.
Bye.